Welcome to this explainer. For years, our most famous former planet, Pluto, has been officially sidelined with the title of dwarf planet. But recently, a massive movement of scientists has been fighting hard to give Pluto its planetary status back. Today, we're unpacking this wild debate, because as you'll see, reclassifying Pluto isn't as simple as just rewriting one line in a science textbook.
Okay, let's dive into this premise. What actually happens if Pluto gets its VIP pass back? Well, it turns out changing the rules that let Pluto back into the club would trigger a massive cosmic domino effect. We're talking about completely redrawing the map of our solar system. You see, this debate isn't just about whether Pluto is special. It's fundamentally about how we define the very word planet. And honestly, which definition is actually the most useful for science moving forward? Here is our agenda for today. 1. The battle for Pluto. 2. The geophysical domino effect. 3. When moons become planets. 4. Chaos in the classroom. 5. American pride in politics. And 6. Nature defies human labels. Let's jump right in. Section 1. The battle for Pluto. This is where the strict rules of astrophysics clash head-on with geophysics. At the heart of this entire controversy is a really fascinating clash over what actually matters: strict orbital dynamics, or a body's internal physical characteristics. Back in 2006, the International Astronomical Union, the IAU, set 3 hard rules for planethood. It's got to orbit the sun, have enough mass to be spherical, and it has to have cleared its orbital neighborhood of debris. Now, Pluto shares its zone with thousands of Kuiper Belt objects, so it failed rule number 3. But the new geophysical proposal, championed by scientists like New Horizons mission director Alan Stern, argues we should just drop that 3rd rule completely. They say a planet should be defined by its internal properties. Its geology, its atmosphere, its shape, not by the rocks floating around it. Under their proposal, you just need enough gravity to be round, and, well, you can't be a star. Now, interestingly enough, both sides of the debate actually agree on this foundational concept of roundness, which is scientifically known as hydrostatic equilibrium, as a baseline requirement for planethood. Think about common asteroids, like Eros. They look like irregular, lumpy potatoes because their gravity is just too weak to overcome the rigidity of rock. But when a celestial body has enough mass, its gravity literally pulls it into a neat sphere. So the debate isn't about the shape itself, it's about whether that shape alone is enough to earn the planet title. Section 2. The geophysical domino effect. Let's meet the new planets. If the geophysical definition actually wins, the borders of our solar system change in an absolute instant. If we totally ignore that rule about clearing the orbital neighborhood, all of our current dwarf planets instantly receive a massive promotion. Ceres out in the asteroid belt, Makemake and Eris in the Kuiper Belt, and Haumea, they all have the mass and the shape to qualify. Because their surroundings no longer matter under this new proposal, their intrinsic geology makes them full-fledged planets on the spot. But hydrostatic equilibrium is kind of flexible, which leads to some crazy results. Take Haumea, for example. It's the fastest rotating large object in our entire solar system. A day there lasts just 4 hours. That brutal speed stretches it outward into a scalene ellipsoid, basically a 3D oval or a rugby ball. But geophysicists point out it has a crystalline ice crust, a rocky core, and even its own ring system. It is a plastic fluid in perfect equilibrium. If it magically stopped spinning, its gravity would snap it back into a perfect sphere. So yeah, under the new rules, we would officially have rugby ball-shaped planets. Absolutely wild.
Section 3. When moons become planets. Location versus geology.
This is where things get incredibly wild. If a planet is defined solely by its geology and its roundness, then our own moon, with its crust, its mantle, its core, and its moonquakes, technically becomes a planet. To a geophysicist, calling something a moon or a satellite just describes its location. It's just what it happens to orbit. It's like saying a wolf isn't a mammal anymore just because of the specific territory it lives in. Our moon is geologically complex, and it wouldn't be alone. At least 19 moons in our solar system, including Jupiter's Europa and Saturn's Titan, are massive enough to be rounded by their own gravity. So, does that make Earth a biplanetary system? Well, while the geophysical rule makes our moon a planet, dynamic astronomers push back using something called the barycenter. The barycenter is the common center of mass around which 2 bodies orbit. For the Earth and the Moon, that point of equilibrium is still 1,700 kilometers deep inside the Earth, so Earth is clearly the boss. But for Pluto and its largest moon, Charon, the center of mass is actually out in the empty space between them. That is exactly why dynamic astronomers point to Pluto and Charon as a true double planetary system, while maintaining that the Earth very clearly dominates the Moon orbitally. Section 4. Chaos in the classroom and the sheer limits of human memorization.
If we accept at least 19 major moons as planets alongside all those dwarf planets, we hit a massive, massive practical roadblock. 110 plus, over 110 official planets. Literally, imagine being a kid in science class trying to memorize that list. We would go from 8 planets to over 110 instantly. And honestly, that number would only keep growing as we discover more round bodies at the far edges of our solar system. And this is exactly the main reason the international astronomical community pushes back. The IAU argues that a list this long destroys the practical utility of the word planet for education and scientific classification. Dynamic astronomers argue that classifying over 100 planets makes it nearly impossible to teach the structural order of space. Think about it. A classification system is supposed to help us organize and understand information, right? If the word planet applies equally to Mercury, Jupiter, our moon, and a rugby ball-shaped ice rock spinning out in the Kuiper Belt, does the word actually mean anything useful anymore? Section 5. American Pride and Politics. The sociological side of the debate.
To fully grasp this whole debate, we have to look objectively at the intense cultural and nationalistic factors at play, especially in the United States. Science doesn't happen in a vacuum, and human emotions play a huge role here. Historically, the visible planets were known since antiquity, and the later discoveries were European. But in 1930, Clyde Tombaugh, an American, discovered Pluto. It was a massive point of national pride. Then, purely by chance, in January 2006, NASA launched the incredibly expensive New Horizons probe to explore the quote-unquote ninth planet. Just 7 months later, the IAU took the title away. Think about that timing. Many scientists leading the charge to restore Pluto, including Alan Stern, were the heads of that very NASA mission. They literally flew a probe to a planet and arrived at a dwarf planet.
The sting of losing the only American planet was so profound that New Mexico and Illinois, the states where Tombaugh was born and worked, passed literal official state laws declaring that Pluto is still a planet. They established Pluto Day and mandated that local schools keep teaching it as the ninth planet. It's fascinating. For much of the world, demoting Pluto was just pure objective science. But in the US, it was a real geopolitical thorn in the side. Section 6. Nature defies human labels. Because ultimately, the universe just doesn't care.
So the crucial point we arrive at isn't just about rocks in space, but about how we as humans try to make sense of them. Human classification systems, whether they're based on strict orbital dynamics or intrinsic geophysics, often conflict with the chaotic, totally label-agnostic reality of the cosmos. The universe exists exactly as it is. It doesn't care about our national pride, our textbooks, or our earthly committees. Pluto, our moon, and Haumea are going to keep spinning and orbiting in the exact same way regardless of the labels we print. These labels, they're simply human tools we invent to try and bring some tiny sense of order to the absolute chaos of the cosmos.
Which leaves us with the ultimate question. Should our scientific labels serve the strict dynamic reality of the cosmos or the practical educational needs of humanity? I'll leave you with that thought to ponder. Thank you so much for joining me on this explainer, and keep questioning the universe around you.